Okay, so a lot of you guys have trouble with relating values, specifically the periods and forces of the satellites to each other through ratios in last week's discussion. So we're gonna go over a similar problem with you guys. So as you see, I've drawn a picture here of like the mass of the Earth and then the satellites orbiting them with the different radiuses, the radii. And just to make it clear that the radius is defined to be the center of the first object to the center of the second object, so just be careful of that. And so in part one, you guys already solved for the velocity equals the square root of big G, big M over little r. And the way that we solved it is that we equated the force of gravity, the universal force, through this expression to equal the centripetal force because it's a circular motion. So for part two, we're relating the periods of the satellites to each other, satellite 1, satellite 2, and satellite 3. And so we can use Kepler's third law to look at the differences and relate the periods to each other. So we know that through Kepler's third law, the period squared is proportional to the radius of the object cubed. So that means that the period is proportional to the square root of r cubed. And notice how the period is only dependent on r here and not on mass. So if we say that the period of satellite 1 equals x, then we can relate the period of S2 over S1 to equal the radius of satellite 2 over cubed over the radius of satellite 1 cubed and the square root of that. And because the two radii are the same, they should be the ratio should be 1 over 1, and therefore the period of satellite 2 should equal the period of satellite 1, which will equal x. For satellite 3, it's a different radius. It's 4r instead of 2r. So we can't say that they're the same. So we have to relate them in terms of a ratio. So that's equal to the root of r3 cubed over the root of r1 cubed. And so you can write it as this. And the radius of satellite 3 is 4r. And the radius of satellite 1 is 2r. It's not r, it's 2r. And so if you expand everything out, you get 64r cubed over 8r cubed. The r cubes cancel, and then you get the square root of 8 over 1 is how the period of satellite 3 is related to satellite 1. So that means that the period of satellite 3 is root 8 times the period of S1, which is equal to root 8 times x.